This is a review about association with two categorical variables. So a quick review about the different types of variables. Categorical variables are variables that are easily sorted into groups. Something like your gender, the neighborhood you live in, or your race. These are all characteristics that are described in words and that you can group people by them. The other type of variable is quantitative data. And these are variables that are measured and they're a number. So a big difference here is this is a word, this is a number. So something like your height, your weight, or a car's miles per hour. So knowing the difference between categorical and quantitative variables. So gender is categorical, zip code is categorical, and grade level is categorical, but our height and our weight are quantitative. So we want to know when we have two of these variables if they're related. And if they are related, it's called an association or a correlation. They pretty much mean the same thing. Association is your broad general term, where correlation specifically is talking about the strength of the association. And depending on the type of variables we have, we use two different graphs. Categorical data uses a segmented bar graph like this, and quantitative data uses a scatter plot like this. So looking at categorical data, we want to know how can I tell if there is an association. And here in this segmented bar graph, I can see that this is about age and blood pressure. And the percent is here. So for this box, that's low. So under 30, low blood pressure is here. 30 to 49, blood pressure is here. And over 50, blood pressure is here. I can see that that percent is decreasing each time for each of the variables. So that tells me that there's something about getting older that increases your blood pressure. I can see like the high, this blue one, here, it gets bigger each time. So something about getting older, your blood pressure increases. So that tells me that there is an association here, because you can see that as your age increases, the size of each of the segments changes. So it's like bigger here and smaller here, and smaller here and bigger here. So there's something about being older that we know that age and blood pressure are related. If there was no association, it would look like this. Each of these segments are exactly the same each time. That tells me that your age is not important here. The percents are going to stay the same no matter what. So association, the size of your bars change. And no association, they all stay the same. So practice question 1, these are associated because the percent changes on each bar. The own category, the dark blue, is bigger for people who are married, and only about 60% for those who are unmarried. So this tells me that people who are married are more likely to own their own home. There's some sort of relationship there. There is no association between housing status and gender. And I know this because the bars are the same, male and female. Both men and women own houses about 70% of the time. That tells me that your gender does not have an influence on it, and there's no relationship here. One thing you want to be careful about is if you are given the data in a table like this, the numbers might be different, right? 132 versus 122. This might tell you that you might think like, oh, more men own their house than women, so there's a relationship, there's an association. But you want to be careful because this is all about percent, right? Percent. It's not about the individual count. It's not about the value or the number. It's about the percent of the total. So it's always helpful to use Statlet and to put the table into Statlet. Don't include the totals, but only the important values. And then you'll get your bar graph and you'll be able to see it a lot easier. So there is an association, again, just because the size of each bar changes.